Hi, it's Balázs here. I just released a new track recently, it's called Cube, and this video is not about go and watch the awesome video I did for it and go to Spotify and take a listen and subscribe and everything. It's rather about the way this song was produced, and why I think it's interesting is because it's not because of I have a plugin which I'm developing together with my brother, but because of I'm using this plugin on all the tracks, and I'm only using this plugin to create sounds and to process the tracks. So this whole song was made in Ableton Live, but it could have been any DAW. And as you can see on the mixer, every track is on 0 decibels, and every pen knob is in the center, so I did not do much in the mixer. I didn't even touch it. So the reason why this is interesting, once again, is that it's not only that I use this one plugin only. The other reason is that everything is synthesized, so there's no samples, not even wavetables. Maybe one synth has a wavetable, but it could have been anything else. It's not. It shouldn't have been a wavetable. Anyways, there's no samples in this track, only synthesized things. And if you took a listen to it, or if you will take a listen to it later, you will hear that the sounds are pretty complex. Sometimes even strings appear, sometimes the drums are, not even sometimes, the drums are sounding pretty organic. So it's not this 808 and 909 drum style, especially on the snares. But let's see what we have got. On the first track we have the pad. This was the initial thing I did, and it sounds like this. It's a pad, and it has two parts. One part is the synth, one part is the effect part. The effect part contains a reverb and a compressor and a gain reduction. So I set the levels here, and it works fine. But if I turn off the reverb, we will hear the pad itself. I had to start the clock once. And now you hear that the pad is based on an arpeggio, and because the clock was not running, the initial sound was also different. With the effect it sounds like this. So this pad is pretty simple anyways. We use the clock, which is this part. So whatever that part outputs, we do some calculations and create a simple arpeggiator which jumps between 1 octave lower, the current octave, and 1 octave higher. And we add it to the pitch of this oscillator. And we have two more oscillators. One is a saw wave, one is a sine wave, and the one that is modulated is a triangle wave, and that's the way this sounds. And we are modulating the pitch of the oscillators as well. And then comes a mixer, where we mix all these guys together, all the three of them. And then we have a filter here. And this is what I used during the sound design phase, but it makes no sense. I just have to patch this there, and voila, same sound. And in the end we have a random pen position every time we hit a key. So yeah, that's the pad, and it's nothing complex. It's just a 3 oscillator subtractive synth. Yeah. Then next is the drums. We have this track called process drums. We won't start with this, we are starting with the main drums. And let me show you how these sound. Let me start the kick, the snare, the clap, the shaker. So let's start with the kick. The kick has two parts. One is the body and one is the transient. Let's turn off the transient and just listen to the body. Yeah, this is the body. And this is a pretty basic synth. It's close to the way an 808 would work. And let me create this scope here so you can see what happens. And let me plug this to a dummy plug so the scope gets some CPU. And we have a trigger signal, and this part is legacy. This way it works nicely. Oh, sorry, shouldn't have moved it there like this. It's nice. So we have a trigger input here, and that means that whenever I wrong key. Whenever I hit a key, whenever the kick kicks in, we have a peak which is one sample long and has the maximum value, and this goes straight into an envelope follower, and that means that it gets a bit of release, exactly 84 milliseconds, an exponential release. And if we feed this signal into a filter, we obtain the resonance of the filter, and that's a sine wave. And the pitch of the filter is modulated, or the cutoff of the filter is modulated based on this envelope in between 300 Hz and 41 Hz, and the resonance is cranked up to the heaven. And that's the way this sound is created. This second filter is set to the same cutoff and same resonance. No, it's zero resonance, it's just the same cutoff as this one before. So this is close to a 24 dB per octave filter. And in the end we have a bit of distortion going on. So this is a soft clipping algorithm, the 10H. It's almost every distortion algorithm uses this function, and we can crank it pretty to crazy values, but anyways, this is nice. And we simply output this, and that's all. This is a kick. But the trick in the beginning with this trigger and putting an envelope on it and feeding that into a filter, you will see this often, so I had to go through this. And this upper part is just a noise burst that we feed to the signal. And this is the body part. Let's listen to the transient part. And as you can hear, this is a pretty basic thingy. It's just two envelopes based on the trigger, and one envelope is just controlling the volume. It releases from 1 to 0 in 9 milliseconds, and the other one is responsible for the pitch. In 2 milliseconds it goes from 2000 Hz to 158.3 Hz, which is the perfect frequency. Of course not, it's just a random value that I liked and sounded good to my ears. And we get this sine signal, so it restarts every time we hit a key. If we didn't do that, it will click sometimes, which is a nice behavior. It's more analog, but I like that I have total control over it, and the two together sound like this. And this is the kick synth. Then there is some processing going on. Let's see what we did to this part. actually we filter. So this is an EQ band, and as you can see, this is a shelving EQ, and it's set to low shelf. But we are not using the regular outputs, we are using the filter outputs, which means that we are outputting the filter part of the EQ, and we send it into a compressor. So this is basically a low-pass filter, or we can call it high-cut filter as well, a shelving high-cut filter. And the compressor is doing some gain reduction, and then this goes into a node called Dynamics, which is my version, our own version of the Dynamics processing. It's a strange little thing, but I use it all the time. I like it from raising up the volume to the heaven. And then this whole thing goes into a mixer, but as far as I can see, it makes no sense to use this mixer, because I tweaked things that they actually make no sense anymore. So actually I could have skipped the EQ as far as I see. No, that makes sense. Then the filter is okay. But the rest signal is pretty... oh, it's muted. That's what happens. So we don't need this part, and we don't need the mixer, and the final sound was nice like this, so I've decided not to use the unfiltered part of the signal. Okay, next is the snare, and this is the main reason why we start with this track, because you can hear it in full effect here. So we have two parts, and let me duplicate this just for the demo. So I turn off those two, and I'm going to show you the things on this one track only, because they are the same. Anyways, I will explain it after the explanation of the snare. So, as you see, the MIDI data comes in, we get a trigger signal, and as soon as it comes in, we multiply it with the scope, not scope, the velocity. And I want to create a scope, that's why I said scope. And this way, let me plug this to somewhere where I'm not using it, like this. This way we get a peak, but based on the velocity. And here we create a longer gate from the trigger, and we send this into the envelope follower. Didn't connect. And this is the attack time basically. And this goes in, here we multiply a white noise with this envelope. And the white noise gets a high pass filter, and I don't know why I did hit the snare all the time, because of everything that matters is just that I should have turned these guys down, and now you will hear the white noise. So this is what we had there. Here we do almost the same thing. Multiply the velocity with the trigger, and then we send it into a envelope which has a release. So we release the trigger signal, then multiply it with the white noise. That means that we are controlling the volume of the white noise with the envelope, which is just a fade. So we fade in 55 milliseconds to silence. And this short burst of noise goes into a filter, which is a two-pole state variable filter, pretty common type of filter. And this filters a frequency. This is a pretty low frequency here. And then the result of the filter goes into the resonator, which is pretty complex something. It's a car plus strong like patch, but in the feedback loop we have two all-pass filters and a dampening filter, and this whole thing, that the second line we have, creates a sound like this. Not much different from the first one, but still not the same. But together they are pretty cool. And on the bottom we have two separate signals that we mix together, and they both use the trigger input as again, and they just create a longer release, and that release time is fixed. And once again we filter them with two filters, and the result is getting added together, goes into a distortion node, and here is some delay in. And if we listen to these guys, it's like that. Oh, sorry, I told it wrong. This is the on number 4 we have the noise. So this is what the upper part sounds like. Yeah, that's... I know what I did. No. This was the first. And this was the second. And the third input is these resonating bandpass filters. So I set this low. And with the sorry. So this is a snare drum. I hope, and sorry for my mistake, I'm not a professional vlogger, but I try to be that. No, I'm not trying to be a professional vlogger. I want to go to Reddit and read comments. Okay, so claps. Claps are not hard to do, since they are basically just white noise filtered with a bandpass filter, and the envelope that shapes them is a bit interesting maybe. And if I show you the shape of this envelope, maybe that's enough. If I can show it, where could it be? Probably, yeah, maybe. No, I made it more complicated. Actually, anyways, this is a clap, and the envelope is like you have a small or several small bursts of noise in the beginning, and then you have a long releasing noise, and the whole goes into a bandpass filter, and yeah, you are happy that you have a clap. And the shaker, it's just filtered white noise. But there's one trick I like to do. If I'm building a sound from white noise, then I like to double the process, so that one white noise signal goes into the left channel and the other one in the right channel, and this way I get a ultra wide stereo sound without panning, and I really much I like this way of working. And by the way, this is what you have seen by the snare, that I had 2 tracks, and this way it has its own room without reverbs and everything. I like it. And these were the main drums. The intro drums are the same, but they use a bit different. These are the drums that appear in the beginning, and then we have a process drum track where we have again a kick, an 808 snare, a snare again, a cymbal, a shaker, some noise, and a clap. and actually the kick is the same. The 808 is just a basic 808 snare. It's just two exponentially releasing sine waves which are generated by a filter, mixed with some filtered white noise, so it's nothing fancy. It's just an 808 snare. I think it sounds nice. Without the post-processing it sounds like this. And we have another snare here, which is the same as before but with other settings, because this is the good thing about this thing that I work with Synth, that I don't have to look for samples. I just alter the patches I did before, and then I have a cymbal here. Without processing it's pretty silent, but let's turn on these guys. The cymbal is a complicated thing. It has some filtered white noise, long releasing filtered white noise that drives itself into 4 comb filters which are in series. So this goes into the next one and next one and next one, and these are dampened comb filters. They have some high pass and low pass filters inside them and in the loop, and the output is just what you can hear. It's a pretty unique patch. I didn't see anyone using this method, but it works for me pretty nicely. And yeah, and after this we go into a bandpass filter section, and that shapes just the way it sounds, because now it's like this, but if I turn on the attack you get this typical cymbal hit. And yeah, where is the release? It's very short. So yeah, this is the cymbal sound. Anyways, this is a preset in Alpha Forever, so it's a nice thing. Clap again, noise burst. That's that's so easy. It's a noise burst. We have a releasing thing, and after that, if I put an attack here, it's the same as a shaker, and it's high pass filtered. So here's the shaker, same thing again. Processing. Yeah. This is a chain of compressors and dynamic effects and EQs. So let's see what we have got. We have a compressor here which reduces the gain. Then we go into a shelving filter, and it's set to high shelf, so we output the high pass filter. We cut the lows with this. That's why there's no low end in this kick drum. Then we go into another EQ, which is a bend, and we just output the bends into a compressor again to shape the sound, and the rest is going into this mixer. And this is multi-band compression actually, because we only use the compressor on one band and the rest is untouched. Then we have another band EQ where we process the frequencies around 85 Hz using this maximizer, and we mix the rest again. And another dynamics in the end to maximize the volume, and if I turn it off, it sounds like this. If I turn this on, it sounds like this. So there is a huge difference in sound. And we have another effect here, for which this is something like the gross beat effect in FL Studio. We can set the delay time based on the clock, and if I start this part with the drums here, you can see that this is a pretty crazy effect. And the thing is that I'm creating these pseudo random numbers, so these are always the same. It's not really random. So this is a gross beat section, this is a filter section that's driven by this envelope, and in the end we have a panorama modulation as well. So this is pretty complex. And in the end we have a compressor that takes care of the gain. And that's all for the drums. Here we have a synth that I could click, and since automation is on, this is going through the whole song almost, and it gives some rhythm. It's a triangle wave with wavetable oscillator mixed, but this could have been any other oscillator, so doesn't really matter. I just chose a random wavetable, and the interesting part is that okay, it goes into a filter section and the filter is automated, but when I move this parameter I change the filter cutoff, and this curve adjusts the volume of this whole patch so that the perception of volume stays the same while I change the filter frequency. Yeah, this patch is more complicated than it sounds. And here comes one of the craziest patches or parts, the sub bass, the growling sub bass. And as you can see, it's nothing like you imagined, so there's no oscillators at all. The way this works is again that I use this trigger, give it some envelope to release, and then feed it into a filter, and let me show you what this looks like in a moment. Plug this here, and so we have the trigger, which looks like the way it looks. Then comes the envelope, and then we filter the high frequencies out of this. And this is the input of, and this is based on the note I play, so it changes when I change the pitch. And this goes into a designer where the output is changing a lot. That resonates like mad, and this is a waveguide actually. And the waveguide is something like a Carplus strong patch or a comb filter, but it's a bit more complicated, as you can see. And this is even not a simple waveguide, because there's all pass filters and dampening happening inside and additional delays, so it's pretty damn complex here. It's hard to explain how it works, and I use the direct output and feed it into the next one, and that outputs the direct signal and feed it into the next one and outputs the direct signal. So it's crazy, and in the end it resonates like mad and sounds weird, and this distortion part takes care of the volumes, so but it sounds so good, at least for me. I like it. Yeah, there's no processing, this is dry. There's another sub which does crazy things again, and it sounds almost like a sine wave, but it's not. If we look at the output waveform, I should have a frequency. I have a frequency here. This is what the output looks like. Actually, this is a bit more loud than it should be, and you see it's a sine wave that is changing its shape, and it's frequency dependent. So, and all is done using these guys. It's crazy, I think. Actually, the way it works is that I have a saw LFO here, which is the phase of a sine wave, and this function changes the saw wave into something else. Let's see the output of this. Yeah, it's a different triangle wave now, and here happens something crazy, and the output looks like this. And if we filter this, it gets weird. I like it. It's so interesting. Okay, melody. If you did listen to the song, you know this synth. It's basically a nicely decaying saw wave, and it goes into a 4-pore filter without resonance, and it just sounds nice. And it has some, not even some, it has a pretty heavy compression, a reverb, and high shelf low cut filter here, and some frequency raise around 2390 Hertz. Orchestral part, which is mainly the strings. No sound here, why no sound here? I know. And since this is again a stereo part, I'm duplicating the strings, and we'll work with this guy here. Yeah, that's good like that. Oh, this part is going to be the... Now it's going to be... Okay. So, let me turn off the reverb. It's here. So this is the string, which is, people would call this physical modeling for sure. We have something that emulates the contact between the string and the bow, and it's basically just a white noise oscillator which is filtered a bit based on the input pitch, and it also resonates like a string or even here, and the output is filtered and modulated based on the velocity and everything, so it's a pretty complex something. And this sound goes again into a part that is called string, which is again a simple delay line with a dampening inside of it, and the length of the delay is based on the pitch we play the sound, and sounds like this. Which is okay. And the other part is called the body, and this is an effect, this is not an instrument, so we process this the whole time. And if I turn this on, it gets more alive. And here is the thing that that takes care of the volume. So this is my string. This is a patch in Alpha Forever by default. And then we have a part that we call brass. This is, I have to give credits to a man called Ken Earhart, who inspired me to even look at synths like they are able to create sounds that mimic acoustic sounds. I think he's a great sound designer, and this brass patch is a good example of his idea. He used simple subtractive synths like this patch, which is more than simple. Let me close these guys. I don't know why Ableton has problems with opening one window only. Anyways. This is a simple subtractive synth with some filtering and two oscillators, two saw wave oscillators detuned from each other a bit, so it's pretty basic stuff. But if we turn on this effect, the sound changes a lot, and this is just we could call it normal formant filter, or on the Polymoog it was called resonator, and it's just three filters which are going to into a mixer, and you can change the volume of the filters, but the filters have different cutoff frequencies, different resonances, and different volumes. So this is not EQing, this is just three bandpass filters. You can see 6 here because it's stereo, but it's just three bandpass filters, and you can do whatever you want with them. In the Polymoog you can set them to low pass, bandpass, and high pass, all of the three filters at the same time. I have the chance to use whichever output I want to for the filters, and I have one low pass and two bandpass filters. And for me this is a nice synthic brass sound, but I really like it. And I have a low and a normal version, same thing, sometimes the low comes in as well. And here are the steps. I don't have to play the rhythm because it plays its own. And this patch is not too complicated, so this is plain basic subtractive synthesis, except that there is a part which takes care of this rhythmic arrangement. I was too lazy to sequence it, and I thought that it's a better idea that it does it on its own. And these I have some features here like repeat, attack, release, and cut off. And the way this sound is made is that I use one saw wave and detuned triangle wave, which is 7 notes higher, and the difference between these two guys is 2 octaves, and another saw wave which has a chorus effect, and it's the same as this, so it's strange. I'm wondering why I did that. Anyways, no, it's 1 octave lower. Okay, and yeah, nice. And this whole thing goes into a 24 dB low pass filter, and it's a happy end in the end. It's pretty basic, but looks more complicated. Then I have a note here called part here called saw pad. It has 2 parts, a polyphonic one, which is just a saw wave that alters the pitch based on the clock. The other part is the filter. And here's some decking on the on this voice. I can create custom decking. Yeah. This effect is called Granular. It's what happens? Interesting. I don't know why I got this. Anyways. And this needs the melody to be active. And you can see how it works. So if I play a note, you can see on this scope like thing that it comes into this granular thing, and I can freeze it. If I turn on the drivet, you can hear what the playhead plays, and I can move around. So yeah, this is a really nice effect, and in the end of the song this effect is automated, and I'm sampling this part and I'm just playing it back. And this is a reverb. It looks like this in the inside. Wow, it's my own algorithm. Cool. And yeah, synth arp. It sounds like a saw wave, but it's not. It's just several comb filters, so this people would call this physical modeling again. It's overcomplicated, compared to the sound that I'm doing with it. Pretty similar results could have been done without this, but I'm stuck in this ultra stereo thing and I'm using white noise to trigger stuff so I can double things up. And there's some processing going on here, like changing the volume. And yeah, the glitch effect that we have seen earlier. And we have a part called Chords. And as you can hear, it's the same patch, but with very low. I play it with very low velocity, so it sounds like a Rhodes piano. This is just volume control. Then this part is just a saw wave, which I play very low. So it's a saw wave oscillator that adds to the rhythm, and low cut, sorry. And in the end we have a part called Swoosh, and for these I've built a module that's where I can draw the attack and release phases. And it works pretty nicely. And this just controls the volume of filtered white noise. And this kicks in before the drums appear in the track. And the thing that is left is the master track, where we have an analyzer part. So if I play this now, everything is silent. You can see that I like to see what I do. This is on the other monitor of mine, on the second screen. And here is a chain that I'm not even using, so I delete this. This is legacy. I use this during the mixing. This part is called Smooth Saturator, and it's like a tape distortion like thing. It changes the amount of distortion based on the signal's actual level, and adds some warmth to the track, if I can call it like that. I don't know, I'm not a huge fan of these kind of things, but I like the way this sounds and I've added to it. It's hard to me to show it now because I've messed up the whole arrangement. And in the end I have some EQs, like raise some frequencies around 1600 Hz and 8000 Hz, and then maximizing the volume. Basically that's it. And as you see, it's not the mastering that made the track, and it's actually this much. So that's it. This is the whole track. You've seen everything, and I hope it was at least a bit interesting and not too geeky. And I hope you had fun watching it, and if you liked it, then subscribe to this channel and check out my song, check out Alpha Forever, check out anything, and yeah, see you soon. Bye bye.